Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. That's one way you can keep me going, inspired and refreshed. Now if you find my videos interesting and important to your studies also, please don't forget to subscribe. So here are problems 50 to 52, still on equilibrium of a particle. Both collars are at rest on the smooth guide bars. Determine the ratio of masses mb over ma. So here's the given figure. Then I have to draw the free body diagram of collar B. So remember, this is a horizontal cable. So the angle that this guide makes with the horizontal is 80 degrees. So the normal will make an angle with the vertical 80 degrees or with the horizontal 10 degrees as shown in the figure. So we have the tension, weight, which is m mass of B times G, then the normal force up to the right, NB, which makes an angle of 10 degrees but not shown here. 10 degrees, by the way, is 90 minus 80. So NB, summation forces, vertical NB sine of 10 minus MB times G equals 0. So that means NB is MBG, where G is 9.81 over sine 10 degrees. Then summation forces horizontal, NB cosine of 10 degrees minus T equals 0. So substituting the value of NB, which is MBG over sine 10 times cosine of 10 degrees equals tension. So that means the tension in the cable, horizontal cable, is MBG cotangent of 10 degrees, or MBG over tangent of 10 degrees. Then for the collar at A, we have tension, MAG, downward. Then the normal makes an angle with the vertical of 20 degrees as shown, normal A. So this is 20 degrees. So from the horizontal 70 degrees, 90 minus 20, but that's not important anymore. So summation forces vertical NA cosine 20 degrees minus MAG equals 0. So solving for NA, it is MAG over cosine of 10 degrees. Then summation forces horizontal, T minus NA sine of 10 degrees equals 0. Then replacing T and NA. So MBG cotangent 10 degrees equals NA, and NA is MAG over cosine 10, quantity times sine of 20 degrees. Cosine of 20 rather degrees times sine of 20 degrees. So cancel out G. This is MB over tangent of 10, and the right side is MA tangent of 20 degrees. So the ratio MB over MA therefore is tangent 10 degrees times tangent of 20 degrees, which is approximately equal to 0.06418. So take note that another way of solving this problem is to draw the force triangle in its free body diagram instead of summation of forces. So you can have another solution if you want, force triangle per free body diagram, and you might find it easier and shorter. For your part, the 50 kilogram cylinder A and the 100 kilogram cylinder B are held inside the crate shown in the vertical cross-sectional view. All surfaces of contact are smooth. Determine the contact forces exerted between the cylinders and between each cylinder and the sides of the crate. So this is the given figure. So I want you to show that the horizontal normal reaction here, which is horizontal, NA at wall is 654 newtons. Then in between A and B, the contact force here, NAB, is equal to 817.5. Then NB wall is of course equal to 654 newtons also. Then NB floor here is equal to 1472 newtons. #51. The masses of blocks A and B are 20 kilograms and 40 kilograms respectively. Determine the value of alpha for static equilibrium. So here is the given figure. Mass of B is 40 kilograms, so 40 G, A 20 G only. So for the free body diagram, I just use the given figure here. This 40 G, let's call that S1, the tension. Here S2, the tension. Then this is also S2. Then later on we'll have S3 for this tension in this cable. Then this is 40 times G for mass at A. So at this first free body diagram, you may have force triangle if you want. So I just use equation. That's the alternate solution, the force triangle. So summation forces horizontal equals 0. S2 cosine of 20 degrees equals S1 cosine of 40 degrees. So that means S1 is equal to S2 cosine of 20 degrees over cosine of 40 degrees. Then summation forces vertical, S1 sine of 40 degrees plus S2 sine of 20 degrees minus 40 times G or equals 40 times G. Substitute replacing S1 by this value. So S2 cosine 20 over cosine 40 degrees times sine of 40 degrees plus S2 sine 20 degrees equals 40 times 9.81. So from here, we can now compute S2. S2 is equal to 347.1 newtons. Then let's transmit it here. Then let's call that S3. That's 20G, then S3. First, summation forces horizontal. S3 cosine of alpha equals S2 347.1 cosine of 20. So that's it. Then summation forces vertical S3 sine of alpha equals 347.1 S2 sine of 20 plus 20 times G, where G is 9.81. So S3 sine alpha is equal to, combining the values in the right side, 314.915 Newton. So next is we divide this equation S3 sine alpha by this equation S3 cosine alpha to cancel out S3 and solve for alpha. So S3 sine of alpha, which is 314.915, and we have S3 cosine alpha, which is equal to 347.1 cosine 20, and that is equal to 347.1 cosine 20. So after we divide, we have tangent alpha equals this value at the right, which is 314.915 over 326.167. So from there, we can solve for alpha. So alpha is equal to arctan of this ratio, 43.99 degrees. Now for your part, block A, whose weight is 90 pounds, is supported in the position shown. Determine the weight of block B. So that's the figure, and show that the weight of block B is equal to 72.73 pounds. So that's for your part. Problem 52. Still on equilibrium of a particle. Collar C is supported by the smooth rod AB and by a spring whose stiffness is 2 pounds per inch and whose unstretched length is 15 inches. The collar is in static equilibrium in the position shown. So determine the weight of the collar. So here is the given figure. So for the free body diagram, we have the weight of the collar, the tension in the spring or the force in the spring, and the normal reaction at C, which is perpendicular to the tangent to this quarter circular arc. So that's T1, stiffness 2 pounds per square inch times delta S. That's the weight, the required, and normal at C, which extended crosses the center there. So if I call this theta, this angle is also theta. And from the figure, sine theta is opposite 6 inches over hypotenuse 10 inches. Sine theta equals 6 inches over 10, so theta equals 36.87 degrees. So for the free body diagram of Collar C, summation forces horizontal first equals 0. So the slope of T1 is 8 over 16, so that's 1, 2 to be reduced, then square root of 5 hypotenuse. Summation forces horizontal and C sine of 36.87 theta equals T1 times 2 over square root of 5. Then T1 is stiffness times unstretched length. The unstretched length is final length minus, the change in displacement is final length, which is square root of 16 squared plus 8 squared, that's the final length, minus the unstretched length of 15 or LO of 15. So T1 equals K times delta S. T1 equals 2 pounds per inch times quantity squared of 16 squared plus 8 squared minus 15. So T sub 1 is equal to 5.777 pounds. Substitute into this equation to solve for N sub C. So N sub C sine of 36.87 degrees equals 5.777 times 2 over square root of 5. So N sub C is equal to 8.6118 pounds. Then summation forces vertical equals 0. So N sub C 8.6118 times cosine of theta 36.87 plus T1 5.777 times 1 over square root of 5, then equals weight. So we can now compute the weight. The weight is 9.473 pounds. Then for your part, the spring has an unstretched length of 14 inches and a stiffness of 80 pounds per foot. Determine the height y corresponding to equilibrium. So here is the y, not there, but it's here. And the spring and the attached weight of 30 pounds. So show that y is equal to 15 inches. So that's it for this lecture, this sample video problems.